So I've got a lot written on this page, but the first thing I want to cover is this section right here. Um, so draw your attention to where I've got the yellow going on. So remember how I told you that the matrices go row by column? So when we label a point in here, so if I were just saying this is matrix B and it's going to have a whole bunch of little b's inside of it, well, I needed to say which one is which. So this is in the first row, first column. So if I put one here, it's still in the first row, but it's now in the second column. If I put another one, it would be in the first row, third column. If I put another one, it would be in the first row, fourth column, so forth on forever and ever. Okay, now that I come here, I have moved from the first row, so my first number is no longer a 1. It is now a 2. So everything in this row, the first number that's right here is going to be a 2 because it's in the second row. Okay, but now this is in the first column, so that's a 1. This is in the second column, so everything in this column, the second number is going to be a 2. Everything in the third column, the second number is going to be a 3. So now here, since I'm in the third row, first column, then now I'm in the second column, but the third row, so I go row by column, row by column, so third row, fourth column. I messed up right here. Okay, so if I had a fourth row, all of these would be 4 because we're on the fourth row. So the first one would all be a 4. First column, second column, third column, fourth column. If I had one 8th row, 10th column, it would be 8th row, 10th column. Okay, so anyways, that's what that means. 8th row, 10th column. Now how do you know it's not the 81st row, the 0th? Well, we don't have zeros, so sometimes I'll even use a little comma if it gets confusing. But anyways, that's the important part on that, is realizing if you ever see something that says find the, what term is A34, that means you go to the third row, fourth column, boom, you've got your term. Okay, I'd go third row, fourth column, well, that's the one right there. Okay, if I said, well, it'd be B though, not A. So if I said B21, okay, second row, first column, whoop, there it is, right there. Whatever number's in that spot is what B21 equals, okay? Now, on the next part, when we add, subtract, solve for x with matrices, they must be the same size. Okay, they have to be the same size. If not, you can't add them, you can't subtract them, you can't solve. So, unless there's, well, not even then, okay? So, there is a way to solve, and it's kind of crazy. You'd have to have some multiplication in there. But for the most part, if we're going to solve for them, they need to be the same size. Okay, so now the first thing is, if I have two matrices, A and B, this is question number 24. I don't remember if you have to do it or not, but it's there anyways. Is it possible that A is equal to B? So I look and I say, well, it is possible. Like right now we have 4 and C. If C were equal to 4, that would be all right. Remember, these are equal, so that means everything has to be the same. If A were equal to 12, that would be okay. Whoa. If B were equal to -1, that would be good. But there's no way that 7 is equal to 6. So is it possible for these matrices to be equal? Not a chance. Because there's no way that A can be equal to B if this entry, if A22 does not equal B22. And those do not equal each other. So there's no way that these can be equal because A22 and B22 are not the same number. Okay, we were going all right because we could have said, well, if A is 12 and C is 4 and B is -1, but then there wasn't a way to say that those are equal. So therefore, these A and B cannot be equal. Now on the bottom, when we add matrices, we add the first like row and column spot to the second one. So say this is B. I add the ones that have the same column and row together. So A11 and B11 get added together. So 3 plus 1 is 4. 2 plus negative 3 is negative 1. Negative 6 plus 2 is negative 4. 4 plus negative 5 is negative 1. 5 plus 7 is 12. Negative 7 plus 3 is negative 4. And that's my answer. Okay, so that's this matrix plus that matrix. So now we're going to move on to solving some matrices. This is question number 43 and 44. It gives you matrix A and matrix B. It says 2 times the unknown matrix X minus B equals A. Well, I'm going to go 2 times my unknown matrix X. If I were to solve for X, I would just add B, right? So 2x equals A plus B. And then to get rid of this times by 2, I would really multiply by its reciprocal or divide by 2, right? It's just easier to, with matrices, to multiply by a half. So those are gone. So x equals 1/2 of not just A, but of A plus B. So make sure you understood that distinction. Okay. So now all I need to do is go A plus B. So, which equals 1/2 of A plus B. 1 plus 2 is 3. 6 plus negative 4 is 2. 4 plus 6 is 10. Negative 2 plus 9 is 7. 3, 2, 10, 7. And now I just take half of it. So that's going to be 3 halves, 1, 5, and 7 halves. And that's my answer. That's what the variable X matrix is. On 44, it says 3x plus A equals B. Okay, I was thinking I chose one that had a number in front. If I had 3A or 2B, you'd distribute that. So just suppose that I had 3A. That means I take all the numbers inside of A and multiply them by 3. So 3 times 1 is 3. 3 times 6 is 18. 3 times 4 is 12. 3 times negative 2 is negative 6. So that's what 3A would equal, okay? So now for 44, if I'm going to solve this for x, I'm going to minus the a over, so I have 3x equals b minus a. Divide by 3, which is the same as multiplying by 1/3. So x equals 1/3 of b minus a. So b minus a, 2 minus 1 is 1. Negative 4 minus 6 is negative 10. 6 minus 4 is 2. 9 minus a minus 2 is 11. Now the order does matter, okay? So you could have gone negative a plus b, but I just go b minus a. That seems to make more sense. Then I have 1/3 of that in front. So 1/3 of 1 is 1/3. 1/3 of 2 is 2/3. 1/3 of negative 10 is negative 10/3. And 1/3 of 11 is 11/3. Okay. All right, so that's how you add, subtract, okay, solve for matrices. Now multiplying is a whole nother creature in and of itself. Okay, multiplying is, it's not that it's overly challenging, but it's a lot longer. Okay, when I have two matrices, M, no, let's not do M times N. So I have matrix A times B. Okay, matrix A is of some order M times M. That's how many rows, that's how many columns. Well, if I am going to multiply matrix A with matrix B has to be the same number right here. It has to be this N. This can be something else. This could be Q for fun. But these two have to be the same. And so it might be possible that you can multiply A times B, but you cannot multiply B times A. They say that the matrices are not commutative, right? So that's commutative property A times B equals B times A. Well, these are not equal with matrices. Okay, so anyway, someday if you get into a further math class, realize that matrices do not follow the commutative property. And so when you start talking about different rules and things, fields or something, closure, um, like anyways, some things like that, these don't possess that because these are not commutative. So anyways, now to teach you how to multiply matrices. So if I have 2, 3, 4, 5, -1, 2. So this matrix has 2 rows and 3 columns. So this is a 2 by 3. So the one over here must have at least 3 by whatever. And just to make it kind of crazy, we're going to do it 3 by 4. Okay, so 3 rows by 4 columns. -2, 1, 3, 4. Whoa, too many. Hold on. 3 rows. Come on. 4 columns. 1, 5, 6. -2, 0, 3, 4, -2, -3. Okay, this is going to be kind of crazy. I know my answer is going to be a 2 by 4, meaning it's going to have 2 rows by 4 columns. So what I want you to do first of all is draw something that has 2 rows. So here's my 2 rows, one above, one below, and 4 columns. Okay, and I'm going to put it up here, and I'm going to show you with those little numbers how things work. If I call this matrix A and this is matrix B. So here's the craziness of how this works. So A11 is multiplied to B11, the first one. And then we're going to go A, still in the first row, 1, 2, but the second column, times B12. Whoops. Second, there we go, B21. That's a mess. So matrices are multiplied row to column. So now this 4 is in the third spot, so that's going to be A13 to this 3, which is B31. Okay, so I multiply those, and then I add them. So here's what it looks like. I'm going to go 2 times -2 is -4. So that's the first row. And see where I'm at in here? I'm on the first row and the first column. So I'm using the first row and the first column. Now I'm going to go the second number, 3 times the second number in the column, times 1. And I'm going to go the third number in the row to the third number in the column. So when we multiply, we go rows by columns. We multiply rows by columns. So first one in the row to first one in the column. Second in the row, second column. Third in the row, fourth in the column. Third in the column. Fourth in the row, fourth in the column, so forth. Okay, so third in the row, third in the column. 4 times 3 is 12. So everything on this top row comes from the top row of this. Okay, and whatever column I'm in comes from the column of the second one. So when I move to the second column on my first matrix, that's the second column under here. Okay, so if I were to do this one, this is my second column, all right, third column, second row. So A2, so it's my second row, and then the B on this first row, so whoops, 2, 1 times B, 1, 3. So second row, third column. And then we're going to add that to A2, 2. So that's the second one. B, 2, 3. Then we're going to have the third one on that row. So see, all these are the second row, third term. All of these are on the third column. So the third row, third column. So all of these rows on A are the same. All the columns on B are the same. So anyways, if I were to do that right here, so 5 times negative 2 is negative 10. Negative 1 times 0 is 0. And 2 times 3 is 6. So now let's just work methodically our cross, okay? So now I'm going to go first row, second column. So the first one in the row to the first one in the column. 2 times 1 is 2. Second in the row, 3. Second one in the column, 5. Multiply those together. 3 times 5 is 15. Third one in the row, 4. Third one in the column, 6. So 4 times 6 is 24. Now I do it again with the third row. So first one in the column, 2. First one in the row, first one in the row, first one in the column. So 2 times negative 2 is negative 4. Second one in the row, 3 times the second one in the column, which is 0. Third one in the row, 4. Third one in the column, which is 3. So 4 times 3 is 12. Now first row, fourth column. First one in the row is 2. First one in the column is 4. So 2 times 4 is 8. Second in the row, second in the column. So 3 times negative 2 is negative 6. Third one in the row, third one in the column. So 4 times negative 3 is negative 12. Now the second row. First one in the second row, first one in the first column. So 5 times negative 2 is negative 10. Second in the second row, second in the first column. It's easier to do than try to say. You guys ought to try to say this out loud. So second one in the row, second one in the column. Negative 1 times 1 is negative 1. Third in the row, third in the column. 2 times 3 is 6. So now I'm still on the second row, but now into the second column. So first one in the second row, first one in the second column. 5 times 1 is 5. Second one in the second row, second one in the second column. Negative 1 times 5. Third one on the bottom row, third one in the second column. 2 times 6. Now we've already done the third one, so now we're to the fourth one. First one in the row, first one in the column. 5 times 4 is 20. Negative 1 times negative 2 is 2. And 2 times negative 3 is negative 6. So now I just add these together. 12 plus 3 is 15. Minus 4 is 11. 2 plus 15 is 16. Plus 24 is 40. 2 plus 15 is 17, not 16. So that makes 41. Oh, what are you guys thinking? So anyway, sorry to lead you astray there. 17 plus 24 is 41. 12 minus 4 is 8. 8 minus 6 is 2. And 2 minus 12 is negative 10. Negative 10 and negative 1 is negative 11. Plus 6 is negative 5. 5 minus 5 is 0. Plus 12. 6 minus 10 is negative 4. 20 plus 2 is 22. Minus 6 is 16. So there we go. That's how we multiply matrices. It's not as slow as what I just made it. I was really trying to explain so that you guys could watch and follow. Once you get doing these, they actually go by pretty quick. And yes, you do have to do it by hand. Okay? If you want to type those in your calculator to check your work, that's fine. But on your test and on your quizzes, if I don't see this for your work, so I have to be able to see this for your work, I will not give you full credit. Okay, on the test, I think it's like 8 points. If you have the answer, you get 2 points out of 8. So realize the work is worth more than just the answer. So I want to see if you understand how they actually multiply. So make sure you go through and learn how to multiply. All right, so on 54, let's work through that by hand. So this is a 2 by 2, and this is a 2 by 2. So when I go A times B, these are going to match up. And when I go B times A, it'll work both ways. So it is a square matrix like this, where these are the same. You can do A times B and B times A. So now, since I know it's a 2 by 2, I know that that's how my answer is going to be, is a 2 by 2. So I'm going to go A times B. So remember, the first one in the row to the first one in the column. So 1 times negative 2 is negative 2. second one, second one. So negative 6 times 7 is negative 42. Now first one in the row, first one in the second column. So 1 times 3 is 3. Negative 6 times negative 1 is 6. So now I'm on to the second row. And I do each column again. So 5 times negative 2 is negative 10. 10 times 7 is 70. 5 times 3 is 15. 10 times negative 1 is negative 10. So when I work this out, that makes negative 44, 9, 60, and 5. Okay. Now B times A. So that's actually going to be this one first. And A is this. They are not the same answer because we are going this row now to this column. So negative 2 times 1 is negative 2. 3 times 5 is 15. Negative 2 times negative 6 is 12. 3 times 10 is 30. 7 times 1 is 7. 1 times 5 is 5. 7 times negative 6 is negative 42. 1 times 10 is 10. So now I combine those. I get 13, 12, 42, and negative 32. Now A times A means that I have 1, 5, negative 6, 10. 1, 5, negative 6, 10. So again, 2 rows, 2 columns. 1 times 1 is 1. Negative 6 times 5 is negative 30. Now, first row, second column. 1 times negative 6 is negative 6. Negative 6 times 10 is negative 60. Now, second row to the first column, second row to the second column. So 5 times 1 is 5. Second one in the row to second one in the column. 10 times 5 is 50. First one in the row to the first one in the column. 5 times negative 6 is negative 30. Second in the row to second in the column. 10 times 10 is 100. So that makes negative 29, negative 66, 55, and 70. Okay. So some of you have wondered how you would do this on your calculator. So I guess I'll show you. I'm going to write down the problems first so that I can remember what they are. So that was 54. So A was 1, negative 6, 5, 10. And B is negative 2, 3, 7, negative 1. So I come to my calculator. I go second matrix, edit, and I pick whatever one. I'm going to pick D. I'm going to make it a 2 by 2. Well, yeah. So 1, negative 6, 5, 10. And I go back to second matrix, edit. Whatever you do, I'd suggest that you keep them like, even though I didn't do A, B, make sure you do like D, E, so you can kind of keep it straight in your head, which one's first and which one's second. So it'd be easier. I should have just done A and B because then I'd know which one I'm working with for sure. So I should have done that. So this is going to be negative 2, 3, 7, negative 1. So now I go out of here. I go second matrix. I choose that, the fourth one, times second matrix E. And there's my answer, negative 44, 69, and 5. So negative 44, 69, and 5. Now if I go second matrix, E times second matrix D. So this is the backwards of it. There's my next one. And if I go second matrix, D times second matrix D. There's the last one. Okay. Negative 29, 55, negative 66, 70. So anyways, that's how that works, okay? So now working on 55, this is 3 rows by 2 columns. This is 2 rows by 3 columns. So when I do A times B, that's 3 by 2 times A 2 by 3. So that works. Those are the same. My matrix is going to be a 3 by 3. When I come down here, B times A, that's a 2 by 3 times a 3 by 2. So A is a 3 by 2. So that works because these are the same, and it's going to be a 2 by 2. When I do A squared, that's going to be a 3 by 2 times a 3 by 2. That does not work because those are not the same number, so not possible. So now let's do A times B. So let's do first one. 2 times 1 is 2. 4 times negative 2 is negative 8. Now first row, middle column. 2 times 4 is 8. 4 times 0 is 0. 2 times negative 1 is negative 2. 4 times 10 is 10. It's not 10, it's 40. Negative 6 times 1 is negative 6. 3 times negative 2 is negative 6. So again, first one in the row, first one in the column. Second in the row, second in the column. First in the row, second in the row, second in the column. Okay? So negative 6 times negative 1 is 6. 3 times 10 is 30. Now I moved on to the third row. See how down here I'm on my third row? First column, second column, third column. So third row, and then each column. So 1 times 1 is 1. 7 times negative 2 is negative 14. 1 times 4 is 4. 7 times 0 is 0. 1 times negative 1 is negative 1. 7 times 10 is 70. So now to get my final answer, 2 minus 8 is negative 6. 8 plus 0 is 8. 40 minus 2 is 38. Negative 6 and negative 6 is negative 12. Negative 24 plus 0 is negative 24. 6 plus 30 is 36. 1 minus 14 is negative 13. 4 plus 0 is 4. 70 minus 1 is 69. Okay? Now I'm on to this one, B times A. And I'm just going to put A over here because I want to go this way. So the first one in the row, first one in the column, 1 times 2 is 2. Second row, second column, 4 times negative 6 is negative 24. Negative 1 times 1 is negative 1. Now first row, second column. 1 times 4 is 4. 4 times 3 is 12. Negative 1 times 7 is negative 7. Now I'm on to the bottom row. So second row, first column. So first one in the first row, first in the row, first in the column, second in the row, second column, third in the row, third in the column. So negative 2 times 2 is negative 4. 0 times anything is 0. 10 times 1 is 10. Now second row, second column. And the first, second, second, last, last. So negative 2 times 4 is negative 8. 0 times anything is 0. 10 times 7 is 70. So negative 24 and negative 1 make negative 25. Plus 2 is negative 23. 4 plus 12 is 16. Minus 7 is negative 9. 10 minus 4 is 6. 70 minus 8 is 62. So anyways, hopefully that helps you learn how to multiply matrices, how to add them. We don't divide matrices, so you don't have to worry about dividing matrices. We just have to multiply, subtract, and add. So anyways, good luck with all that, and hopefully you'll be able to work through those quicker than it took me to explain them. So good luck.